Hello, everyone, and welcome to today's webinar. We are excited to have you join us as we explore how BricsCAD streamlines the entire survey workflow, from raw field data all the way to polished and construction-ready deliverables. Leading today's session is Zava. She's a civil engineer with 9 years of experience in. Oh, sorry. Can you hear us now? Okay, thank you. So, leading today's session is Ava, a civil engineer with 9 years of experience in AEC industry, and she's our solution consultant. Ava specializes in helping teams to optimize their work through using integrated DWG platforms. Her background spans 2D drafting, civil and surveying workflows, and 3D modeling, point clouds, and BIM. And she's passionate about simplifying the tools that the AEC professional relies on this today. In this session, Ava will guide you step by step through BricsCAD Smart Survey workflow, importing field data, organizing points intelligently, creating accurate site models, and generating the documentation needed for real-world project delivery. So once again, thank you for joining us, and let's get started. To you, Ava.
Thanks so much, Jin, and hi everyone. Great to have you today. To give you a quick roadmap of where we're headed, this is what we'll cover in the next hour or so. First, we'll start with a brief introduction and look at some of the common industry challenges you might recognize and where BricsCAD fits into that picture. Next, I'll share a short customer success story to show how this works in the real world. After that, we'll jump into the live demonstration of the Smart Survey workflow inside BricsCAD. And finally, we'll wrap up with Q&A, so feel free to drop your questions in the chat as we go. Before we dive in, I'd like to get a quick sense of who's in the room. On your screen, you'll see a poll. Please choose which option best describes you. Whether you are a surveyor, a civil engineer, CAD or BIM user, a project manager, or something else. Let's wait for a few moments for the poll. Okay. Going once, twice, and we're closing the poll. I see a lot of us are land surveyors here and some others. I'm very curious what are the other attendees right now. Feel free to type it in the chat box to describe what your profession is. Okay. Hold on, going back to... Thank you for those answers. Now, let me tell you why we're here today. Whether you're in the field, collecting data, or in the office processing it, I'm sure you've experienced some common pain points. Let me walk through 4 challenges that I've personally encountered, and I know many of you have too. First, there's the sheer volume of data. I've been on projects where Surveyors come back from the field with 800, sometimes 1,000 data points. And you sit there looking at all of this thinking, what now? Because here's the reality. Maybe a third of those points are trees, bollards, utilities, property boundaries, and you need all of that information to accurately represent what's on site. But you also need to sort through it all, categorize it, and make sure it's showing up correctly in your documentation and plans. And it's time consuming, tedious, and honestly, it's easy to miss something. Then comes the complexity of creating accurate terrain surfaces. On paper, turning a set of survey points into a clean tin sounds straightforward, but in reality, it's rarely that simple. You're managing break lines, cleaning up stray or bad points, dealing with gaps and edge issues, and if something is wrong at this stage, it affects every contour, every section, and every volume calculation that comes after it. And here's where I've spent more late nights than I'd like to admit. Cut and fill calculations. They're tedious, error-prone, and time-consuming. You're manually checking sections, recalculating volumes, making sure every parameter is correct, then going back over it all again because you want to make sure that the numbers are right. One mistake and you're redoing hours of work. Of course, there are specialized software tools that can handle this automatically, but they come with a hefty price, and we'll talk about that in a moment. And finally, the tools that you need often come with a hefty price tag. You might need one tool for data management, another for surface modeling, a third for cut and fill analysis, and maybe a fourth for reporting. And before you know it, you've got multiple subscriptions, multiple licenses across your team, steep learning curves on each platform, and a budget that's getting harder to justify to management. These four challenges are interconnected. Solve one and it helps the others. So the question becomes, what if you could handle all of this in one integrated platform? That's where BricsCAD comes in. But before I show you how, let me quickly answer the question you might be asking. What exactly is BricsCAD? So, what is BricsCAD? At its core, it's the true CAD alternative. A professional DWG-based platform built specifically to solve the problems we just talked about. And what makes BricsCAD special is that it is actually built on machine learning and AI to make your workflows smarter and faster. You get native 2D, 3D, BIM, and civil tools all in one integrated platform. No jumping between software. And if you're coming from legacy CAD platforms, you'll feel right at home because the interface is familiar. No steep learning curve. Behind BricsCAD is Bricsys, a major technology company, part of the Hexagon Group. So you know this is a serious platform solution with real backing and support. So Bricsys has a truly global footprint with headquarters in Ghent, Belgium since 2002 and regional offices across North America, Latin America, and Asia Pacific. But what's equally important is our extensive partner network. We work with resellers and partners worldwide. This means wherever you are, you have access to local expertise, local support, and partners who understand your market and help you get the most out of BricsCAD. Now you might be wondering, which BricsCAD product is right for me? We have one DWG-based platform with different levels tailored to what you do day to day. Lite is great for 2D drafting, while Pro adds robust 3D modeling, point clouds, and civil and survey tools, particularly valuable for those in surveying and civil engineering, though useful for many other workflows. On top of that, manufacturing and building, we have BIM and mechanical. And if you want all of these capabilities under a single license, BricsCAD Ultimate simply unlocks the full set within the same BricsCAD platform. Here are some of the workflows BricsCAD does really well. You will see capabilities across 2D, 3D, BIM, and mechanical design. But today, we are zeroing in on civil and geospatial, which is where your survey and terrain workflows shine. Now let's get back to what we came here for, the survey workflow. Let me show you exactly how BricsCAD addresses each of these challenges we talked about earlier and how it transforms your process from start to finish. Here's exactly how BricsCAD solves each challenge. Data overload meets smart data import. Powerful tools to automatically organize, filter, and structure your survey data so you only work with what you need. Difficult terrain modeling becomes intelligent surfaces, fast and easy tin and grading generation. Volume inaccuracy gets automated analysis, cut and fill reports in minutes. High software costs disappears with our cost-effective and unified platform, one affordable solution from data to deliverables. So you can see here that there is a clear alignment between the challenges and how BricsCAD addresses each one. But don't just take my word for it. Let's hear from RealServe, one of our customers in Australia and New Zealand, who work with a wide range of surveying projects and use BricsCAD in their day-to-day workflows.
There are a number of factors that were critical in our decision to
Ava, do you want to pause it and rerun because there's no sound?
Okay, let me try that again. Sorry about that.
There are a number of factors that were critical in our decision to cross to BricsCAD, and they were the flexibility of their licensing model, the customer service and partnership approach. Having that sort of relationship with our software partners is incredibly important to us. But when we did our cost analysis before making the switch to BricsCAD, our estimated savings were in the order of about 15%. So that's allowed us to reinvest those funds into other aspects of the business, technologies, training and staff, which all again adds to better productivity and customer service.
The functionalities that we use from BricsCAD are precision drafting, the coordinate geometry or cover points or civil points called in BricsCAD, and integrated external survey data like point clouds from 3D scanners and total stations. We use tin surfaces to create contours and any heat maps for flatness level surveys. The biggest benefit is the fact that we can use total station data, point cloud data, drone data, all into one software. Everything is in just one spot and anyone can open it and understand the data.
As far as the transition process goes from the older CAD system into BricsCAD, it was a lot more smoother than I had first anticipated. Within about a day, we were up and running. The user interface was very, very customizable. We were able to import our older user interfaces into the new BricsCAD software, which is probably one of the main contributing factors as to why we got up and running so quickly. Working with point cloud technologies has also been seamless thanks to BricsCAD. So we've been able to not worry too much about the system lags and crashes. I've seen drafting times reduced by, it can be anywhere between 10 to 20% depending on the type of project using BricsCAD.
Here at Bricsys, it's really important that we do have a customer journey in place. We're focused really strong on making sure the customer gets the right value out of the product, that we've met their needs, and more importantly, that we've supported them through their change management strategy. So in regards to the team here at RealServe, we believe the product has been able to resolve a lot of the current pain points that they were facing, but more important, it's been able to enhance productivity to their team and obviously save time and increase the amount of revenue that they're getting as an organisation.
We're able to either send an email or put a phone call through and have someone attend to our support needs straight away. And that makes a big difference, because if we've got an issue, it generally means somebody's not able to work on a project, and that's costing us money.
It's a more efficient and streamlined system to operate. Anyone that needs to touch a CAD-based system in their day-to-day should consider BricsCAD.
So that's a great example of how BricsCAD supports real project in the field. Now I'm curious, how many of you are currently working with tin surfaces? On your screen, you'll see a poll. How do you typically create a tin surface in your workflow? Just select the option that best matches your current process. We'll just wait for a few seconds to have everyone give their best answers. And by the way, we also do apologize for all the technical glitches that's been happening. Thank you for understanding. Okay, and we're closing the poll. I see a lot of us are still really using the classic way of importing your CSV or text files. So thank you for that, for sharing that. And as you can see, of course, while a majority of us is using importing from civil points, there are different ways teams approach tin surface creation. Today, we're going to focus on the most common workflow, importing from CSV files. So here's exactly what we're going to demonstrate today. A complete end-to-end workflow with 5 key steps. First, we import field survey data from a CSV file directly into BricsCAD. Then, we create accurate tin models for our terrain model. Next, we design grading solutions and run cut and fill analysis to see exactly what we're moving. And from there, we generate cross-sections and volume reports, the deliverables your contractors need for cost estimation and coordination. All of this happens in one platform. And last but not the least, we have documentation. As you can see, one platform, one file, without jumping between software. So let me walk you through each step. Let's start at the very beginning with our field data. So I've got a CSV file from the survey team, so I'll go ahead and import that. You'll notice that on import, we already have options to assign point groups, symbol styles, and label styles. But for now, I'll keep things simple and bring the data as it is. Once the points are in, if I click on any civil point and open the Properties panel, you will see all the survey information attached to it. Northing, easting, elevation, and I can also see the symbols and change the style directly here if needed. What we really want is to turn these survey points into a terrain model. Creating the surface is just one click, and just like that, it is now generated. Now that the tin is in place, we don't need the civil points anymore, so I'll turn them off for clarity. I'll rename the surface to NS for natural surface. And then I'll adjust the visualization by turning off the triangles and turning on the contours so it's easier to read. Next, I'll just turn on the site layer. Here, you can see two rectangles. One represents the building site over here, and the other one represents the staging area over here. So we'll start by creating grading pads from these two footprints. For the building site, I'll create a grading with a 30-degree slope tying back to the natural surface. Once this is created, you can take a look at the properties panel and you can immediately see the cut and fill volumes for this pad. You can see how easy and fast it was. Now we will repeat the same process for the staging area, and again, I'll use a 30-degree slope so both platforms tie cleanly into our existing terrain. Now that our pads are in place, we need an access road between them. For that, we'll use a string. So I'll start by launching the string, and the first string will be on the grading pad, and I will snap to the edge of the pad as the next point. From there, I'll continue with a grade of 2% along the straight section. Then, at the turn, I'll create an arc segment with a 1% grade. And then finish the straight line down to the staging area. Once this is done, this will give us a smooth, controlled vertical and horizontal alignment between the two pads. Once we're happy with the string, we can turn it into a natural road surface. I'll create gradings for this one with an offset of 5 meters on each side. So I'll specify the start, which is the edge of our site grading pad, and the end is the edge of our staging area. Now I'll do an offset of 5, and we'll do the same thing on the other side as well. Selecting the string, offset, specifying the start point and the end point, and our 5-meter offset. Then I will tie those edges back with a natural surface with a 5-degree slope. So using the dynamic input, inputting the 5 degrees, and we'll do that on the same side as well. The nice thing about this approach is that the string stays fully interactive. If I change a parameter from the string editor, for example, for, let's say, our third segment over here, changing this from 1% to 10%, you will see that the model updates and the gradings recalculate automatically. It's a very dynamic way to iterate on design without starting over. So right now, our access road is made up of several grading pieces. To make it easier for us to manage and visualize, we'll merge these into a single surface so it behaves as one continuous access road. This gives us a cleaner model and simplifies the downstream analysis. Now, let's look at earthworks. We'll create volume surfaces, comparing each design surface against our natural surface so we can understand our cut and fill. As you can see, we have to do it for each of these surfaces. And you will see your volume surface at level 0 of your z-axis. And when clicking any of these volume surfaces, you will see the volume statistics tied to it in the properties panel. To make the analysis clearer, I'll turn on the elevation analysis and I'll define some ranges with the datum. You'll notice once we apply this, there will be a color coding. Areas in red represent the cut, and areas in green represent the fill. So I will apply the same setup for the other design surfaces, so we have a consistent visual read of all three. Then we will just apply this. And once we understand the volumes in 3D, the next step is cross sections. Now I'll create the section lines based on the string we drew from the access road. And here you can control things like section width and interval between sections. But I'll keep the default settings for now. And with now the section lines in place, we can generate the section views. Now this is where it gets interesting. We can assign the sections to a specific layer, pick a section view style, or even create a new style on the fly. So I'll just name my section view style here, and I'll set a vertical exaggeration, let's say 5 times. I'll just adjust the text height and some offsets, and I can also customize the label content so key properties are shown. So with the horizontal axis, I'll just tweak the minor intervals and also the text height for the major and minor labels. The same goes for the vertical axis. I'll just do the same. Last but not the least, we have here the display. And I'll just change the color grid lines of the major and minor grid lines so that it's a little bit lighter and we can see the sections a little bit easier. Then I'll just change the center axis to something like yellow. Selecting that, and I'll adjust the distances between the rows and the columns for proper placement of the section views. For the data sources, we can map each of the surface to a layer so colors and line types follow our template. Once that's configured, we will simply click Create and simply place the section views on the sheet. And you can see how clearly and beautifully the design is represented here. Since volumes are often tied directly to cost, let's generate some reports. I'll first rename my volume surface so it's obvious which area each one refers to. So the first one would be our site. The next one should be our access road. And our third volume surface would be the staging area. Once we have these in place, generating the actual volume reports is just a guided series of steps. Essentially as easy as 1, 2, 3. Now we'll just place that somewhere here, and you can see the table. The results can also be exported to CSV if you want to do further analysis or integrate with your own costing tools. So just repeating the same process and then clicking Export to CSV. We'll just save this as volume report. And once this is saved, and we can open this directly into our spreadsheet, and we can continue doing further costing. The last step in the workflow is documentation. If you already have a standard title block that you use in your organization, you can bring it straight into BricsCAD and reuse it. Here you can see my title block with attributes that I can quickly populate. I can change the project title, created by, date, and so on. Once you click OK, it will populate your title block right away. Creating viewports works just like you're used to. I'll run the viewport command, draw a window, and then I'll just place my section views, or I can even set the appropriate paper scale here. And with that, we've gone all the way from raw survey CSV data to a complete documented set of outputs: surfaces, gradings, cross-sections, volume reports, and plotted sheets inside one environment. Before we move into a short bonus segment, I'd like to understand how you're currently handling one key part of this: earthwork volumes. On your screen, you will see a poll. How do you currently calculate volumes? Please pick the option that best matches your current setup: manual spreadsheets, CAD-based tools, dedicated earthwork software, outsourcing, or others. Going once, twice. Now we're closing the poll. I see a lot of us are using CAD-based tools, and some are using a dedicated earthwork software. Thanks for sharing that. That gives us a good picture of where everyone is today. For those interested in taking the front end of your workflow to the next level, here's a quick look at how AutoMap transforms raw survey data into a fully organized, standards-compliant drawing automatically. Watch what happens when we apply intelligent point mapping. In this demo, I'm starting with a drawing that already has a background map, so we're ready to bring in some real-world data. Our surveyors have been on site surveying and exporting data to a CSV file. Let's drop that in. Our CSV file has, other than the coordinates and level, of course, the point code, and in some cases, different attributes. As you can see, all the points are imported using the default setting, so they just appear as generic points. But in this template, we already have symbol styles and label styles defined for different codes. So don't worry, I'll recap those in a moment. Now, by creating a new auto mapping setting, we can take all the points we imported and populate the codes. This displays all the unique codes on the left, and from here, we can assign the appropriate symbol style, label style, and layer to each code. So once this process is completed, for all the codes, we can simply apply auto mapping. And in just a matter of seconds, the drawing is transformed from anonymous points into a fully customized dataset with the right styles and layers applied automatically. Before we move on, let's quickly revisit the settings. As a reminder, labels can include all the information you need. In this example, for control points, I choose to display the easting, northing, and elevation, along with a point description. But let's have a quick look at some additional setting we can use with auto mapping. If the correct attributes are assigned in the field, we can also add a scale to the entity. A good example is the tree spread. The command automatically recognizes the attribute and adjusts the scale accordingly. Another good example would be the rotation. By adding an angle attribute, the manhole will be displayed parallel to the street, giving our drawing a more realistic appearance with all the entities displayed. Using the right symbols and labels, our drawing will not only look more realistic, we can also standardize the output across the company, minimizing repetitive work and simplifying the overall procedure. That was a quick look at how AutoMap can take care of the repetitive work for you. Organizing points, applying the right symbols, labels, and layers in seconds instead of hours. To wrap up, I'd love to know how this lands for you. On your screen, you will see our final poll. How interested are you in automating survey data handling, for example, with AutoMapping? Please pick the option that best reflects where you are today. Okay, we can see a very landslide result. We'll close the poll now. I can see that a lot of you are very interested in the auto mapping feature. That's very great to know. And that's it for today. Thank you for all your engagement and the great poll responses. We're now opening up the floor for questions, so please drop yours in the chat box and I'll go through them one by one. And while we're in the Q&A, you can also scan this QR code to try BricsCAD for yourself after the session. I see a question here. Is there any options to import the points data directly from the total station? It depends on what total station you're using. If you have a Leica equipment, you can directly use your Leica software directly into BricsCAD. And then we also can import Land XML files. Yeah, and then if you also use point clouds, you can also use that as well. Also see questions. Yeah, the same. Does the BricsCAD support point clouds and Land XML files? Yes, BricsCAD Pro and above support point cloud import, visualization, and tin surface creation. What about long sections? So right now we do have vertical sections, but for the full profiles with labels, please stay tuned for our next releases. This will be a future release. The product team is working hard to make this possible as soon as possible. Are there any limitations when using two tin surfaces to calculate the cross-sectional volume? So far, based on what I've encountered, I don't think I've seen any limitations when you're trying to compare two tin surfaces to create your volume surfaces. VBA support, yes, we do have VBA support. We do have full list. You can also edit your list routines directly in BricsCAD. We also have Python support for Python as well. Can this workflow be standardized across teams? Yes, by using your templates for layers, styles, and settings, different users can follow the same steps and produce consistent drawings and reports across projects. Is BricsCAD actually owned by Hexagon? I am just specifically integrated with the Leica and future proofing. Yes, we were acquired by Hexagon, and we are under the Hexagon umbrella. Can you show the render or walkthrough part? Unfortunately, rendering is not part of the workflow today, but we do have a lot of YouTube videos on our YouTube channel that shows some rendering or walkthroughs for various types of projects. Yes, for the alignment, we do support horizontal and vertical alignments. We also have basic corridors as well. Can we directly import Civil 3D file? So Civil 3D is a DWG file. You can simply open that in BricsCAD. It will have proxy objects. You can also convert these objects into BricsCAD Civil objects. So you'll be able to read the data from your Civil 3D file. Does it require plug-in civil site design for more detailed work? It depends on what type of work you're doing. So everything that I showed today is just natively on BricsCAD. So if you need to do more advanced like road design, site design, then you would probably need civil site design as a third-party add-on. Is it possible to use an already prepared contour map instead of a civil point under the same workflow? Yes, of course. So in creating your tin surfaces, we have various ways on how you can create your tin surface. One of them is from contours. So you can use those lines, those lines, those contours, and create your tin surface from this. Any option to get optimum earthwork calculations? So far, the workflow process that we have here in BricsCAD is just creating your tin surface, of course, as accurate as possible, and then you can have the option of rounded edges or cornered edges for your volume surfaces or your grading pads. Then using your tin surface and your two tin surfaces to compare those and find the difference, which is the volume surface. Please share learning resources for BricsCAD. You will find more learning resources on our website, and we also have a learning portal that you can find through our website as well. So I'm just trying to go through some of the questions. I might have missed something. Are there functions to generate strings from points using attributes imported from a CSV file specifically for creating break lines? This one would be, this is still something that is under development, so stay tuned for future releases. Training providers in Western Australia that offer courses in civil surveying applications. Yes, you can feel free to contact our local partners, and they can offer you some trainings on the civil and survey applications. For AutoMapping, the survey point is the center of the manhole. Yes, and but it also depends on how you did the surveying or how the surveyor took the survey points, of course. If they took it at the edge, then they need to specify that it's at the edge. Question, bridge design can be possible. For a full-on design, we would suggest third-party applications. So you can browse our website. to see all the possible third-party applications that you can use. I think that's it for our questions. If there's anything that I missed out, please feel free to send me an email. My email address is flashed on the screen right now. We also have a short survey that will pop up on your screen, so please take a minute to fill it in, and your feedback really helps us improve with our future sessions. With that, I'll hand it back to Jin to wrap things up, and thanks everyone for joining today.
Yes, thank you, Ava. Thank you, everyone, for joining us today. We appreciate that you could fill up the survey so that we know what kind of topic you would like us to cover for the next session. So without further ado, I'll wishing you a good day, and we look forward to seeing you in the next webinar. Thank you.
Bye. Thank you.
Bye.